I'm unable to plumb the depths of physics or scale the heights of physics, whichever it is. But I wonder if you could explain to us non-physicists the Yang-Mills theory.
You know what the fundamental physics is about is to ask how matter is put together. In the 19th century, finally, people realized that everything is made of atoms and molecules. In the 20th century, we learned that the molecules are made of atoms. Atoms are made of protons and electrons and neutrons. But what are protons and neutrons made of? Now we know they are made of quarks. So that is one aspect of what we do. Namely, we want to take matter apart and look at the constituents. But there's another part of the endeavor, namely how these parts are put together. The reason that they are together is because there's a force between them. Force is in daily language. In physics, we call it interaction. So the question is, what are the interaction between these constituents? Interaction of force is well known already since Newton's time. There's gravitational force. And through the 19th century, we know there are electric and magnetic forces. In the 20th century, we know there are two additional kinds of forces. They are called nuclear forces, which are responsible for the atomic bomb.
Nuclear forces.
Nuclear forces. And weak forces, which are responsible for such things like radioactivity. So there are now four types of forces. The question is, what are the precise nature of these four types? We know that the gravity through Newton is a inverse square law. You probably learned that in high school physics. So you might say that the basic question that one of the fundamental basic questions we face is how are these three other forces structured? They are not inverse square laws, but what are they? And that's where the Yang-Mills theory or gauge theory comes in. Gauge theory gives a principle which governed how these forces are structured mathematically, precisely. And when Mills, originally in 1918 and 1919, stimulated by Einstein, Hermann Weyl, a great mathematician, proposed what is called gauge theory. He used that to describe electricity and magnetism, and that was successful. But it does not apply to the other two, the nuclear forces and weak forces. Mm-hmm. And what Mills and I did was we generalized what Weyl did. And that becomes a general principle of forces, of why they are these forces, including gravity. And that principle is now called the gauge principle. Mm-hmm. And the gauge principle's detailed mathematical structure is what we wrote down in 1954. At the time that we wrote it down, nobody believed that it was important, and we didn't know it was that important, but we said that this is a beautiful idea, and the mathematical structure is very elegant, so we published a paper about it. And then 20 years later, various experiments showed that in fact was approximately the right direction. Then after struggling for another 5 years, it became clear that it's not just approximately right, it is exactly right. So that became something which is now the universally accepted principle of how these forces are formed.
1954.
Yes.
How do you feel about that? The fact that 50 years later, something that you created, that you propounded, has been so fundamentally has so fundamentally changed your field?
Well, of course, I feel good about it. But I tell my students that the structure of everything oftentimes has hidden beauty in it. If you can sense vaguely some of this beauty, do not let go. The reason that in 1954, Mills and I were able to do it, as I told you, it was not in agreement with experiment, and nobody believed us. But we saw the beauty of the structure, so we wrote it down.
The elegance of the structure.
That's right.